Hi everyone, this is Rahul from Learn with ER. So today's video we are going to do Cayley Hamilton Theorem from matrices. In the last video we talked about the eigenvectors and eigenvalues, and I'm sure now you'll be able to solve questions from that particular topic. Now today we are going to talk about the Cayley Hamilton Theorem. So let's start with the Cayley Hamilton Theorem. So we will divide this video into two parts because there are two basic applications of this theorem when it comes to questions from matrices. The first application is to find the inverse of any particular matrix, and the second application is to find the higher power of matrices in terms of lower powers. Okay, so in today's video we are going to solve the inverse of a matrix using this particular Cayley Hamilton theorem. So let's solve the inverse of a matrix. So before we start the Cayley Hamilton theorem, let me tell you more about this particular theorem. The Cayley Hamilton theorem also has that same kind of approach, just like that for finding out the eigenvalues and vectors. That is determinant A minus lambda I determinant equals to 0. So using this particular approach only we are going to solve and find out the inverse of the matrix, but it's a little different from the video which we did over the finding out the eigenvalues and vectors. So let us do a question through which you'll be able to understand more of this particular approach. So let us write the question first. So the question goes like this. Again, you are given a matrix. Let's say this is 1, 3, 4, 2. A is given as 1, 3, 4, 2, and we have to find what is the value of A inverse, and we are using Cayley Hamilton theorem to figure out this particular question. Now see, when you find the A inverse, we usually have this formula, right? A inverse is given as adjoint of A transpose of that divided by determinant of A. So this is the normal formula which we have for solving the A inverse. Now using this Cayley Hamilton theorem also, we will be able to find out the inverse of this particular matrix. So let us find out how to find the inverse. So I will start with putting the characteristic equation of Cayley Hamilton theorem, which is exactly the same like the eigenvector and value. So characteristic equation equals to, so this is the solution which we are doing. So the characteristic equation is given as modulus, sorry not modulus, it is determinant A minus lambda I equals to 0. Okay, so we will follow the same process just like we did in order to find out the eigenvalues. So we will start with modulus, a determinant, and A is like 1, 3, 4, 2 minus lambda, then the unit matrix, as I've told, it's a 2 cross 2, so it will be 1, 0, 0, 1 and equals to 0. So what we conclude from here, so let me rub the thing. So the final conclusion that we make, one line we will add. So it is determinant of 1, 3, 4, 2 minus lambda 0, 0 lambda, and final form comes like 1 minus lambda, 3, 4 and 2 this one shall give me 0. Okay, so that is the final form. Now we are going to put the quadratic form of the equation. So if we put the determinant of this matrix, we will get 1 minus lambda into 2 minus lambda minus 4 into 3, that is 12, equals to 0. So if we multiply it, so finally the thing that we get will be lambda square minus 3 lambda minus 10 equals to 0. You just need to calculate this and simplify this particular equation, and you are getting this particular value. So let me take it as equation number 1. So this is the equation, after which what we did, we found out what is lambda, what are the values of lambda, and then we could find out what is the eigenvalue, just we did in the previous video. Now here we are going to apply the Cayley Hamilton theorem now. And the Cayley Hamilton theorem says that whenever you find this particular quadratic form or whatever the equation is regarding the lambda, you just need to convert this particular lambda into the matrix A. So instead of lambda, I'm going to write A. Wherever there is lambda, I'm going to write A. So that is the format of doing the Cayley Hamilton theorem. Okay, so I'm keeping the equation number 1 intact, or I can write it again, not a problem. So I'm rubbing everything. So let me write the equation 1 again. So equation 1 was given as lambda square minus 3 lambda minus 10 equals to 0. This was equation 1. Now, using Cayley Hamilton theorem, we have to replace this lambda into A. So it will be A square minus 3A minus 10 into I equals to 0. Why? Because the previous equation was a quadratic equation, right? So this was a quadratic equation and basically it was a polynomial. But here, don't you think that is not a polynomial? That is exactly a matrix, because A is a matrix, and when it comes to matrix, this number 10 cannot be alone because it won't be participating in the process otherwise. So you have to convert this particular number into a matrix, and that is by adding it with a unit matrix. That is why this I has come. Okay, so whenever you are writing an equation in the form of a matrix, whenever there is a singular number, you have to multiply it with I. Okay, so this is how I have converted the lambda into A. Now what we can write here is, so we can take this 10i to that side. So what we have, and we can take A common from here. So A taken in common will give A minus 3i again. I hope you have understood why I have written I here, because again 3 will be singular, otherwise if you take A from 3, it will be just 3. But then again, since this is in the matrix equation, so I have to introduce I, and that will be equals to 10i. That will be equals to 10i. Now again, we can write this I as A inverse. A into A inverse, we can write this I, right? So if we replace this one, so we are getting A and A minus 3i will be equals to 10A into A inverse. Okay, so it will be 10A into A inverse. So this A and this A will get cancelled. Okay, this A and this A will get cancelled. So ultimately this A inverse can be written as A minus 3i by 10. A minus 3i by 10. Now this 10 can be kept as a number. Why? Because we are going to write it as 1/10 a minus 3i. Okay, so what we are going to do is we are going to find out the answer of this one, and then we are going to multiply 1/10 with the particular matrix that we get. Okay, so the final form that I'm getting, now I just need to convert. Let us make it as equation number 2. So this is the equation of A inverse. Now I'm going to find out the matrix form of this particular equation. So let us skip it and let us now find out the matrix form. So A inverse can be given as 1/10. Let us take it and let us keep it in the outside the second bracket. So A is the matrix that was given to us, that is 1 3 4 2. It is A 1 3 4 2. Then minus 3i. So I is 1003. 1001. So 3 multiplied with that will be 3003. That will be the total of 3i, and that will be the total of A inverse. So again 1/10, and we are getting the final matrix, that is 1 minus 3 gives minus 2, 3 minus 0 gives 3, then 4 minus 0 again gives 4, and 2 minus 3 gives minus 1. So you can keep it like this, or you can also write by multiplying this inside. So it will be minus 2/10, which is equals to minus 1/5, then 3/10, then 4/10 or 2/5, and finally minus 1/10. So you can represent this particular answer like this or like this. So that is how we are getting the value of A inverse by using the Cayley Hamilton theorem. So that is the first part of the Cayley Hamilton theorem, where we have solved the inverse of a matrix. In the next part, we are going to solve the conversion of higher power of a matrix in terms of lower power. So please keep watching, and we will meet on the next video. Take care.